The other algorithms that we are going to learn is logistic regression. Logistic regression is the very basic binary classification. Binary classification means there are two classes. Okay? Yes or no, good or bad. Like this one, spam or not spam. And you can also have the examples in the assignment. It is clickbait or not clickbait. Okay. So if there are two classes, then it is binary classification. For the logistic regression, it is good for binary classification. And it models or sigmoid function. So what is sigmoid function? This is the function. So we have the probability of C given X, it is on the 1 divided by 1 plus E. E is an Euler numbers, power of this function. So we have minus beta 0 plus beta 1 x1. It means this is the coefficient for the x1 plus beta 2 x2. So this is the coefficient for x2 and so on until the beta n xn. Basically, this is similar to the linear regression. So the composition of this one is similar with the linear regression. But in the logistic regression, we use the sigmoid function. It is to make it more into 0 and 1. 0 and 1. So logistic regression learns weights or coefficient for its feature. We want to get the weight or the coefficient. So in this case, we want to get the beta 0, beta 1, beta 2, and so on for its feature or word to predict whether a sentence belongs to sports or not sports. So this kind of weight, we can calculate based on the probability. If the word appears a lot, then maybe this weight is high. When the word appears less, weight maybe also small. So we can create this kind of binary like what you already learned on the previous table. Okay. So X is the features, and for each of the column, it represents the word. Okay. It is the word a, the word a, the word grid, okay, the word a, the word grid, the word game, the election, and so on. So we will make it into X. So X, this one, it is the sentence 1. This is the sentence 2. This is the sentence 3. This is the sentence 4, and this is the sentence 5. So you can have this X, this is the features to determine whether it belongs to sports or not sports. So let's assume that the sport is 1 and not sport is 0. then I can make this kind of y. This sentence belongs to sport. This sentence belongs to not sports. This sentence belongs to sports. This is sport and this is not sports. Then we can have the x, which is the feature, and we have the y. This is what we want to predict, or this is the class. So I will skip the process to get this because there are several ways to get the weight. We call it this weight. Some of the weight, it is statistical ways. For example, we can calculate with the probability, and then we calculate based on the average of the appearance of every other words. Okay, I already have this weight. So this is the model after we train into the. So we have the weight is 0.2. We have the word great. The weight is 0.5. So we call this is the beta. So the beta 1, and this we can represent with the x1. Let's say this is great. So we have the beta 2, which is 0.5. And we have the x2. It represents the word great. And so on. So the next word is Kim. So it means the beta 3, it is 0.8. And the word Kim, it is x3. Until we have until the word close. Okay, so we have this beta 14. And then we have the x14. Something like this one. In the linear regression and also in the logistic regression, we have the beta 0. Okay. Beta 0 means the intercept or the coefficient for the initial value. So if everything is 0, so what is the initial value? So let's assume the intercept term, or the sometimes people use the theta, sometimes people use the beta. So let me use the theta here. Theta 0 is 0.1. Okay, so the beta 0 is 0.1. Now, with the word of very close scheme, how can we create the features? So this is the feature. The very close scheme, is 1. What about grid? 0. And then game. Okay, we can see there is a word game. The word the is 0, 0, 0, 0. Right? Is 0. This is the word very. The word very, there is 1. And 0, 0 close. Okay, we have 1. So if there is the word, then we put as 1. If there is no word, we put as 0. So we can calculate what usually we call it as Z. Z, yeah, it is the if I mentioned to you before, the beta 0 plus the beta 1 x1 plus the beta 2 x2 and so on until the beta n xn. Okay. So we want to do the summation for all this one. So the summation is this one. So this is the beta 0. So the beta 0 is the intercept. So I would like to produce the Z, and just put all the numbers. we have the 0.1 for the beta 0 plus the beta 1. What is the beta 1? In this case, we have the word oh sorry, the word the word the beta 1 is 0.2, and because it appears in this text, so I just multiply with 1. So this is the binary x1 equals to 1 because the word appears, and then the next word is this one, came. Okay, the word came, we have the beta 2 is 0.8. 0.8. We know that this word appears, so we multiply with 1. Next, came. Oh no, the next is very. Okay. Very is 0.1. So 0.1 is the beta 3 multiplied by 1 because it exists, and plus by the word close. The word close, it is also appearing in this text. So 0.3 multiplied by 1. What about the other? 0. 0 multiplied by 0 will be 0. Then, of course, 0, 0, 0, 0, 0, 0. So we don't care with this one. We do care only with the words that appear in this test. So we can get the value like this. Z is 1.5. Okay. So we can put this into the formula that we had before. The formula for the logistic regression, so we want to get the probability. Okay. So the probability is 1 divided by 1 plus E with this formula. So this formula, it is on this one, and we can just replace. So this is minus Z. Okay, so Z is this one. Then the result is 1 divided by 1 plus E power of minus 1.5. So the number is 1 divided by 1 plus 0.2231. Then the probability is 0.8176. So this value will be the value to determine whether it is belonging to class 1 or 0. Since the value is higher than 0.5 or it is closer to 1, okay, 0.8, it is closer to 1, then we will classify it as spots. Okay. That's why I mentioned last time, when you do the exam, please bring your calculator, because you may get some problems to calculate this one. Okay. So please try first with your calculator how to get this value. Now, there are some kind of notes before you do the algorithms. There are some assumptions. For the naive bias, the assumption is independent. So there is no dependency between the features. That's why they call it naive. For the logistic regression, there are no strong assumptions. So it means that they will check the relationship between the words. They use some weighting. Okay, they use the weight in order to check how big is the weight for that particular word in the sentence. The training time. The naive bias is fast. because they just calculate, okay, how many times. So it is a kind of linear search. Of course, yeah, if linear search, it depends on the number of the data. If the number of data is n, yeah, then if you still remember with the algorithm class, you have the big O n time. If linear time, it is considered as hash. In the logistic regression, actually, it is moderate. We need to optimize the weights. So there are some mechanism how to get the weight. The output of the naive bias is the class probabilities. But the class probabilities, you need to get the P for the class 1 and the P for the class 2. And then you need to compare. But for the logistic regression, with class probabilities, when you get the class probabilities given x, then check. If it is higher than 0.5, most probably it belongs to class number 1. Lower than 0.5, then most probably it belongs to class 0. So the interpretability, it is based on the probabilities. But for the logistic regression, weights provide feature importance. Okay. So let's get back to this logistic regression. So I run this one on the simple logistic regression in Python, and this is the result. Now, if you look at this 0.2, this is positive. Okay. Then it is important when you create the word and if you have the word a. What about this? Negative. So when you have the word over, it decreases the importance. Okay. So the weight represent whether this word important or not in your new sentences like this one. It means if you have the word the or election was over, it may decrease the probability into 0. If you have the positive one, you may increase to 1. Okay, so that's the meaning by the importance. In the knife, the features, but in the logistic regression, you can interpret the features. So which algorithm do you want to choose? It depends. Okay. So now I'm just giving you two, the naive bias, and there are options like multinomial naive bias. Okay. You learn about multinomial naive bias and Bernoulli. What is the difference? Based on the frequency. Okay. The Bernoulli based on the binary axis or not axis. Okay. It is simple, fast, and work well with small. So if your data set is small, for the assignment, yeah, the actually 30,000 is still small. There are so many texts. So it is effective for the text classification. For logistic regression, it is more flexible and more robust. but it requires more data and tuning, especially effective when the feature independence is not assumed. Okay. Now let's see some other techniques to improve the modeling. Yeah, you can include the text examples that I give to you. I do not remove the stop words. Okay, if you look at the example, you still have the you still have the. Make the probability high. Lemmatized the word. So later on, you will see. Let me open the assignment. Okay, so you can have some idea how to do this. The word girl, okay, with S. And maybe later you will get girl without S. Female. Female represent the same meaning with girl. So how can we deal with this one? So there are many issues. Okay. And for example, we have many numbers. 29, 13, 23, which is something not that important for this one. So how can you handle that one? Okay. So you also need to understand how to deal with the text representation. Either you want to use the n-grams or you want to use the TF-IDF or use other kind of representation. Here I give you some other algorithms. Maybe if you join the data science class, yeah, you know SVM, or you want to use the neural network or other things, okay, or you use the pre-trained models, yeah, it's also possible. So let's go to the Google Colab. So in the Google Colab, I put everything, okay, all the libraries. I think you know already the pandas, numpy, re, the regular expression, string. It is to get the function related to string. And then we can select the data for the training and the testing. And then we can do the feature extraction. Feature extraction means use the frequency, or you want to use the binary, or you want to use other things like the TF-IDF. Now let me just use the count. So it means I'm just using. So there are some algorithms like the multinomial naive Bayes, logistic regression, and then I want to use the accuracy for the performance. And I'm also using the log loss or the cross entropy loss, like what we learned before. So I'm using the stop words to check if there are stop words in the sentences. Let's filter it. So this is just the sample. Okay. So this is 20 random complaints. The text is, my street light is not working for a week. There's a water leak that needs fixing immediately. Trash pickup has been delayed by a day again. The pothole on Main Street caused a flat tire, and so on. Okay, so this is the complaint. So I want to set up the class. So the class here, we have 1, 2, 1, 2, 1, 2, 0. Okay, what is it? So 0 means not urgent. 1 is normal, 2 is urgent. So this array or this list represent the class for every of the sentence. For example, we have the first sentence. My street light is not working for a week. Okay, this is considered as a normal complaint. What about the second? There is a water leak that needs fixing immediately. Okay, we have to work immediately. So maybe because of that word, it becomes urgent. Let's see the third one. Trash pickup has been delayed by a day again. So the category is one. So it is not urgent. And so on. We have this class. So I already gave you some of the function. Okay, last time I also give you the functions to do the pre-processing. So you can choose anything for the pre-processing. Let's say I'm doing the lowercase and I remove the punctuation. I remove the white space, get the stop words and remove the stop words. Okay, so this is the basic pre-processing. And oh, sorry, I need to run this. Okay, so I get the clean corpus. Okay. The clean corpus means the text that already filtered. It is not including the numbers. It is not including the punctuation, no white space, and no stop words. So we get the street light working weak. There's water leak needs fixing immediately. So you can see the word there's something, an issue here, but we don't have any issue with if some of them also contain that similar word. Now let's say I'm making the text representation, unigram, bigram, trigram. Okay. So to factorize, it will be the unigram, bigram, and trigram. So this will be the representation. Okay. The shape is 20 multiplied by 207. So I'm going to split the data. I think if you already joined the data mining, you know how to test the training and the testing. So the training is the training data will be 1 minus the testing. So if the test size is 0.2, then the training will be, yeah, the algorithm here, I'm just using the very basic one, the multinomial naive Bayes and the logic. We fit the data and then predict. Using the logistic regression, we fit the data and predict. Okay. So we have the output. So let's, yes, and what is the output of the logistic? Okay, the naive Bayes, the accuracy is 0.25. Oh, very low. For the logistic regression, the result is 0.5. Okay. Maybe this is because the data is too small. Okay, then the accuracy is also very low. The cross entropy is 1.5, and this cross entropy is 1.1. The perplexity is 4.8, and this perplexity is 3.0. So you can see that the perplexity, if it is lower, this is better. The accuracy, if this is higher, then this is better. Okay. For your assignment, yeah, you can use this code as well, and then check what will be your standard. Let's say I'm using the standard of logistic regression. The accuracy is 0.5. Then it means for the creativity here, improve the current algorithm performance. So improve the logistic regression. The logistic regression is now 0.5. Then what is the alternative? As I mentioned to you, there are many other kind of algorithm. Maybe you want to use SVM. Yeah, you can try. Or you want to use the neural network. You can try. So just try one algorithm to improve this result. Okay, so that will be the score for the creativity. Okay, so yeah, you learn about the text classification use case, the prediction and the classification variance, and about the algorithms. Actually, in the collab, I give you one algorithm which is called LDA. So LDA is one of the important algorithms in the text classification. I give you the example. So using the LDA, the accuracy is 0.5. So it does not increase the accuracy from the standard algorithm, which is the logistic regression. Then, yeah, for the creativity, please figure out what will be the better algorithm to improve the accuracy. Okay. Okay, that's all for today.